In the last section, we started talking about the internals of Node.js, and we had said that the purpose of Node is to give us a nice, consistent API for getting access to functionality that is ultimately implemented inside of V8 in libuv. I want to give you a very concrete and practical example of how this actually works behind the scenes. So in this section, we're going to go through a little bit of an exercise. This is going to be a lot of fun, but it is going to revolve around kind of clicking around to a lot of different pages inside of our browser. So we're going to look at some different documentation and some source code, but along the way, you'll get a much better idea of what Node.js is really doing for you and me. So this exercise that we're going to go through is this right here. Here's what we're going to do. So at the very top, we're going to first start off by picking out some random function inside the Node standard library. We're then going to try to find where that function is implemented in the Node.js source code. So like the actual source code that comprises the Node project. And then once we find that source code, we're going to figure out how Node leverages and kind of wraps functionality that is implemented inside of libuv8 and libuv. So this is going to be a really fun exercise, and it's going to give you a much better idea of how Node is internally structured and how it works. So step one is to pick a function in the Node standard library. Now, I had said that we were going to pick a random one, but in truth, I already picked one particular function out, and this is going to be a function that we're actually going to use quite a bit later on inside the course as well. So the function that you and I are going to investigate is called, well, let's pull up an example of it right here. Here we go. It's going to be a function called pbkdf2. So that's the actual function name right there. And I know that's a really weird function name. It's the name of an algorithm that is used for hashing some arbitrary data. So this is a function inside of Node's crypto library. And usually it is used to hash a password for storage inside of a database. So again, I know it's a weirdly named function, but it's just the name of some hashing algorithm. That's all. So let's take a look at the actual implementation of pbkdf2 inside the Node codebase. And as we go through this process, you're going to very quickly see how Node internally makes use of libuv and the V8 project as well. All right, so I'm going to pull up the Node.js source code on github.com. If you want to follow along, you can open up your own browser and go to github.com node.js/node. All right, here we go. So here's the Node repository. This is all the source code that you have already installed on your computer when you installed Node. Inside this repository, you're going to find a bunch of different files and folders, but there's two folders that are very relevant for what we're trying to do right now. There's the lib directory right here and the src directory right here. The lib folder contains all the JavaScript definitions of functions and modules that you and I require into our projects. So you can think of this lib folder right here as being like JavaScript world, or the JavaScript side of the Node project. Then inside the src directory is the C++ implementation of all those functions. So the src directory right here is where Node actually pulls in libuv and the V8 project and actually fleshes out the implementation of all the modules that you and I are used to using, like the FS module, the HTTP module, and so on. So let's first get started by looking up that pbkdf2 function inside this lib folder, and we're going to find the JavaScript definition of that function. So inside of lib, we're then going to find the internal directory, which is right here. We'll then find the crypto directory right here. And then finally, we'll find the pbkdf2.js file. Here it is right here. All right, here we go. This is a JavaScript file that contains the JavaScript definition of the pbkdf2 function. And remember, this is a normal function that is just included inside of the standard library of Node. You're going to find that the contents of this file looks very much like a JavaScript file that you and I might write. So at the very top, you'll find a bunch of require statements. In the body, you'll find a bunch of function declarations. And then down at the very bottom, you'll eventually see an export statement as well. So here's where the actual pbkdf2 function gets exported from this file. Let's go up a little bit and we're going to find where this function actually gets declared. All right, so right about here on line 16 or so, you'll find the definition for PBK-df2. So if you and I were to require in this function and then run it from inside of our code base, this is the function that would get executed. Now this next part that we're going to go through is going to be just a little bit complicated because I'm going to very quickly kind of run through some of the source code that is executed anytime we call this function right here. But eventually we're going to end up on another part of the code base that starts to take us to like the C++ side of Node.js. So anytime you run this PBK-df2 function, it does a little bit of error checking, it does a little bit more error checking, and then eventually it calls underscore PBK-df2. So let's find the definition for underscore PBK-df2 and see what happens inside of there. So I'm going to scroll down, and then on around line 32 or so, you'll find the definition for underscore PBK-df2. Inside of here, you'll again see a bunch of error checking, just a bunch of error checking stuff. You know, all the stuff is error checking. And then eventually, you'll see this block of code around line 72 or so. So right here, you'll see a call to another function called PBK-df2. And it takes in all the arguments that were passed to our current function and passes them to this PBK-df2. So this right here is where that hash is actually calculated. Essentially, Node.js takes all the inputs that you provide to this function and it forwards them on to the C++ implementation of this function. So this PBK-df2 thing right here, in all capitals, this is a C++ function. Let's see where this thing actually gets required into this file. If you scroll back up to the top, you're going to see around line 9 or so where we require in PBK-df2, and that's coming from a very unfamiliar looking require statement. So this says process.binding and then crypto. This line of code right here is how Node.js joins up the C++ side of its project to the JavaScript side. So I'm going to show you another diagram that's going to help flesh out the process of all the code that we've looked at so far. All right, here we go. So at the very top, again, is our JavaScript code. Then we went into the Node JavaScript side of the Node repository to look up how that function, PBK-df2, actually gets defined. We looked up a file inside the lib folder, which is all the actual JavaScript code works, and we found that eventually it looks like that PBK-df2 function is defined from something called process.binding. That process.binding thing is what connects the JavaScript world to the C++ world of the Node.js project. Let's take a pause right here. I know we're in the thick of things, but let's take a pause right here. We're going to come back in the next video, and we're going to start to explore what that process.binding thing does and how it joins up to the C++ side of the Node project. So quick break, and I'll see you in just a minute.